Good morning, good afternoon, good evening. Welcome back to Chapter 21. We are currently digesting food. We started with the process of ingestion. We brought the food in. Ingestion has another name, and that other name is called mechanical digestion. Mechanical digestion takes place in the mouth, takes place in the crop or gizzard, and it finishes up in the stomach. In the stomach, and actually in the mouth too, the second step of digestion occurs, and that is secretion. Secretion is all of the various liquid products that we're going to add to this food in an attempt to break it down. What is the first liquid product that we add to a meal when we try to eat it? And the answer is saliva. Saliva is our first secretion that we add to the food. Now, the saliva obviously is made by salivary glands. Salivary glands, depending on the animal, will make this stuff called saliva that contains a few different compounds. Example, in our mouth, in our salivary glands, we make a product called salivary amylase. And salivary amylase, its job is to break down complex carbohydrates. Salivary amylase. Salivary amylase's job is to break down complex carbohydrates like starch, things like that. An experiment you can try at home: take some popcorn, preferably unbuttered, unsalted, or a piece of bread or a piece of cracker, and take a small bite of it. Not much more than like a dime-sized bite of it. Chew it up, mash up your front teeth. Keep it towards the front of your mouth and mix lots of saliva into it and turn it into a slush. You might need to leave it to stay in your mouth for as long as 5 minutes. But if you do that, this popcorn or cracker or bread will eventually start to taste sweet. And the reason why it tastes sweet is that starch, cornstarch, bread starch, starch is just long chains of carbohydrates. It's just long chains of sugar molecules. But because it is a long chain of sugar molecules, it does not activate our sweet receptors on our tongue. But if you leave it in your mouth, the salivary amylase will be a pair of chemical scissors and will take those long chains of carbohydrates and will snip them and cut them up and turn them into short chain carbohydrates and eventually down into mono and disaccharides, which do activate your sweet receptors. So those starches that you take in, pasta, breads, things like that, potatoes, they all get turned into sugar pretty darn quick. Yeah, French fries gets turned into sugar like almost immediately once it gets into your stomach, because starch just gets turned into short chain by this stuff called salivary amylase. Some animals will have not chemicals for breaking down carbohydrates in their saliva. They'll have chemicals for breaking down proteins in their saliva. So, the meat version of breaking down popcorn. And specifically animals that will have that are animals that make what we refer to as venom. So think of the venomous snakes that we have around here. We've got copperheads and cottonmouths and rattlesnakes. Those do specifically, their venom contains what we call proteases. Remember, ace means what? It means enzyme. Enzymes do one of two things: either make something or they break something. A protease is an enzyme that breaks down proteins. So most of the venomous snakes in America will contain proteases in their venom, and the whole point of that is to break down the muscle in the prey that they eat and to turn that muscle into a liquid. And so when the snake finally finds and eats the mouse or the rabbit or whatever it was, it's basically just a bag of jelly because it's been broken down, it's been digested inside. Because yes, they do have teeth, but their teeth are not for chewing or ripping or tearing. Their teeth are only for holding. Those front teeth are for injecting. But after that, their teeth are just for holding. They're not for cutting, they're not for tearing, they're not for chewing. They're just for holding to keep the prey from getting out of their mouth. All right, so we secrete stuff onto our foods. The first organ that is going to secrete stuff into the food is going to be the mouth, and specifically the salivary glands in the mouth. The esophagus doesn't really do a whole lot. It's really just a tube. It just kind of connects it, escorts the food from the mouth to the stomach, but it doesn't really add anything to it. The stomach now is going to start secreting some stuff onto the food that we eat. The stomach will secrete, number one, hydrochloric acid. Now, if I were to ask you the question, what's the job of the stomach? We know the job of the stomach. The job of the stomach is to digest your food. Well, we all know that stomach acid is something that the stomach makes. So what is the job of stomach acid? Well, if it's the job of the stomach to digest the food, I would imagine that stomach acid, its job is to digest food, and that is not the case. Stomach acid's job is to sterilize your food. Stomach acid's job is to kill microorganisms, kill any kind of bacteria or pathogens that are in the food that you eat to keep it from making you sick. Stomach acid is not for digesting your food. It does make some digestive enzymes work better, specifically some of the proteases that get released by the stomach. But for the most part, stomach acid's job is simply just for sterilizing your food. Stomach acid is what gives vomit its distinctive flavor. The stomach is going to do some more carbohydrate digestion. It'll complete that carbohydrate digestion. It's going to begin protein digestion. Once the stomach is done with the food that I've eaten, once it's done with this chyme, it's going to release that chyme to my next organ in line, and that is my small intestine. In the small intestine, there's a little opening where the pancreas, which is kind of up underneath of the stomach, where the pancreas releases what we call pancreatic juice into this chyme that comes out. Pancreatic juice contains a lot of things. It contains nucleases, it contains lipases, it contains more proteases, it even contains an amylase for doing more carbohydrate digestion. It contains digestive enzymes for breaking down a whole bunch of stuff. The pancreas's job is secretion. Its main job is to release all of those things that are going to break down our food. To do this second stage of digestion, the first stage of digestion is mechanical. The second stage of digestion is called chemical digestion. Mechanical digestion is taking a big piece of food and making it smaller. Chemical digestion is taking a big molecule of food, like that long chain of starch, and to make it smaller by cutting it up into single rings. Proteases will take that long protein and cut it up into amino acids. Lipases will take those long fatty acids and will cut them up into 2 carbon sections like we talked about in Biology 1. Here we see the stomach. This is the esophagus. So the food comes down the esophagus. This is a human digestive system. The food comes down into the stomach. The stomach, obviously some saliva will come with it. The stomach will add stomach acid to it. The stomach will add a protease to it. So again, that secretion. We're going to secrete a number of things onto this food that we ate, and then the stomach is going to be mashing and crushing and mixing all of that up so that it's a uniform paste. And paste is a wrong word for it. It's more of a uniform slurry. Well, like I said, we've all seen what vomit looks like. When the stomach is done with all of this digestion that it does, it's going to send this chyme, and remember I said if it's in the stomach, it's specifically called acidic chyme, because what does the stomach add to it? It adds acid. The stomach is going to release this acidic chyme to this very first section of the small intestine. This very first section isn't very long. The very first section of the small intestine is about a foot long, not quite. And it's called the duodenum. Some people say duodenum. The stomach releases fluid to the duodenum. The pancreas, like I said, the pancreas kind of sits above, or behind and below, rather. Behind and below the stomach. The pancreas will release its pancreatic juice into this duct, which will release fluid right here again into this first section. The liver and the gallbladder we've not yet talked about, but we'll in just a minute. They both release bile. The liver makes bile, and it's the gallbladder's job to concentrate it, which means to remove the excess water. You've probably known someone who's had their gallbladder removed, and we'll talk about what bile does and how removing the gallbladder actually affects the diet. So the stomach releases fluid to the small intestine, the liver releases fluid to the small intestine, the pancreas releases fluid to the small intestine, and the gallbladder releases fluid to the small intestine. This very first section, called the duodenum, this very first section receives fluid from 4 separate organs.